Greetings, students. Today we're going to discuss practice test 6 for geometry. Let's begin. Question 1, find the distance between the points. So I've got the distance equals the square root of x2 minus x1 plus y2 minus y1 squared. So the x's here are negative 6 and positive 2. So this is 2 minus negative 6 squared. The y's are negative 5 and positive 5. So this is negative 5 minus 5 squared. So here I've got positive 8 squared. And here I've got negative 10 squared quantity, negative 10 squared. So this is 64 plus 100, which is the square root of 164. That does divide by 4 evenly, so 2 root 41. Again, I usually skip straight to the 8 squared and the 10 squared by asking myself the x's are how far apart. Well, negative 6 to 2 is 8. The y's are how far apart. Well, negative 5 to 5 is 10. All right, next item, find the midpoint, the middle value between the x's and the y's. So negative 8 to negative 10. So my y values go negative 8. What's the middle of negative 8 and negative 10? Negative 9. Negative 9. My x's, what's the middle of negative 8 and positive 2? Negative 3. Negative 3 and negative 9. Again, you're looking for the middle. You add and divide by 2. So half of negative 18 is negative 9. Half of negative 6 is negative 3. Question 3, set these equal. Take 2 from 65 to get 63. And then take 63 divided by 3 to get 21. Question 4, these two angles are complementary. So 3x plus 36 will be equal in value to 90. So therefore 3x will be equal in value to 54. 3 into 54 will be 18, which is my value of x. Next item. Question 5. I'm going to do the x and the y-intercept separately. So I'm going to set 2x equal to 12. So in other words, I took the x value, set it equal to 12. That gave me the x-intercept, which is at 6, 0, because 2 into 12 is 6, and that's an x value. So this crosses the x-axis at 6. The other one here is negative 3y equal to 12. So I set the y value equal to 12 here, the y coefficient equal to 12. So this will give me the y-intercept, which again is on the y-axis. So this is 0, negative 4. Negative 3 into 12 is negative 4. We'll connect those two together. We have our line. Question 6. We're going to add the shorter lengths here, 11 plus x minus 7. That's going to equal the entire length, negative 5 plus 2x. So taking x from 2x and then combining 7 and 11, so I got 4 is equal to negative 5 plus x. Because negative subtracting x from 2x yields x. 11 minus 7 is 4. Adding 5 to 4 is 9. X is 9. You can check your work. 9 minus 7 is 2. 11 plus 2 is 13. Negative 5 plus 18 is also 13. Find the area, multiply and divide by 2. So 10 times by 6.1 divided by 2. Base times height divided by 2 for the area of a triangle. So half of 61. 30 and a half or 30.5 square meters. Base times height divided by 2, area of a triangle. All right, factoring. My goal here is negative 13. I have 6 by 5 makes 30. So breaking down the 30 into 13, we're going to have to use a negative 10 and a negative 3. So when I take negative 10 divided by 6, that doesn't divide, but it does reduce into negative 5/4, 5/3. So that is 3a minus 5. And when I take negative 3 divided by 6, that does reduce, doesn't divide, but does reduce, makes negative 1/2, so that is 2a minus 1. I do intend to make these worth 4 each, these factoring questions. Moving on to the next page. So on this next page, question 9 through 12 here. These should be in different spots, but they're not on this particular Practice test. So I should have one where it's alternate interior, well, one where it's alternate exterior, one where it's same side, one where it's corresponding. Again, the interior is in between the parallel lines. So the interior, these are the interior sections of the lines. Interior, not interior. These are the interior sections, and the exterior is not in between the two parallel lines. So these are the exterior sections of the lines, the top and the bottom, above and below. These are the interior sections. So alternating sides, meaning alternate sides, meaning change the sides of the transversal. One's on the left, one's on the right side of the transversal. The transversal being this line that cuts the two lines. So this is alternate sides and they're inside. Let's rearrange this question. Instead of putting x there, put x here. That makes this question now into a same side interior. So these are both still interior. They're in between the parallel lines, but now they're on the same side of the transversal. So same side interior. Let's rearrange this one and put the y at the top. Now one of these angles is interior and one of them is exterior. So this is a corresponding set. One's interior, one's exterior. They're in the same spot. And then be exterior for both, alternate exterior. That would be a good example of alternate exterior right there. I do have one of each on the test. That's why I rearranged this. So you'd have one of each here. All right. Question 15. Converse, inverse, contrapositive. Converse, switch the statement around. If he doesn't live in Mexico, then he lives in Utah. Inverse, negate both statements. If he doesn't live in Utah, then he lives in Mexico. So if John doesn't live in Utah, then he lives in Mexico. Contrapositive, we do both. So if he lives in Mexico, then he doesn't live in Utah. John. If he lives in Mexico, then John doesn't live in Utah. The original statement is true. If he lives in Utah, he doesn't live in Mexico. There's no Utah in Mexico. That means the contrapositive is also true. Converse and inverse here. If he doesn't live in Mexico, that doesn't mean he lives in Utah. He could live anywhere but Mexico. The converse and the inverse have the same truth value as well, so those are both false if one of those is false. All right. Write a converse and then write this biconditionally. So I'm going to switch the statement around. If A is equal to C, then A is equal to B, and B is equal to C. And the biconditional, A equals B, and B equals C, if and only if A is equal to C. So let's figure out if this is true. The original statement is the transitive property of equality. If A is B and B is C, then A is C. In other words, C replaces B in the first statement because B is equal to C or C is equal to B. The converse of the statement, is it also true? If A is C, then A is B and B is C? Well, if A is 4, so if A is 4 and C is also 4, so 4 is equal to 4, well then 4 is equal to B and B is equal to 4. Yes, that is a true statement. This is a property of equality. If A is equal to C, then A is B and B is C. What I'm saying here is that B equals itself. Yes, B is equal to itself. B is equal to B because C can replace A. Or B can replace A, actually. So yes, that is a true statement. All right, question 17. This should have a picture. I forgot to have the picture drawn here, and I did the same thing on the test. I may just have it drawn on the board for you, rather than having that or rather than having you have to draw it for yourself on the test. But anyways, the picture should be a vertical angle set where we have 4 angles. I have a picture that looks like this. And again, this is the same picture on the test. So it's worth your time to draw it here in the notes, or on the review, I should say. And this should be a 4, a 5, a 6, and a 7. So given that angle 5 is equal to angle 6, that's my first statement. Angle 5 is congruent to angle 6. Prove that angle 4 is equal to angle 7. So the vertical angles here are angle 4 and angle 5 and angle 6 and angle 7. So I can stay here using vertical angles that angle 4 is congruent to angle 5 and angle 5, angle 6 is congruent to angle 7, because those are the vertical angles, 4 and 5 and 6 and 7, 4 with 5 and 6 with 7. So now what I'm going to do, I want to prove that angle 4 is equal to angle 7. So I'm going to use a substitution to replace angle 5 with angle 6, because angle 5 is equal to angle 6. So this is going to be angle 4 is congruent to angle 6 now, because angle 4 can be replaced, angle 5 can be replaced with angle 6. And now using the transitive property of equality, because 4 is congruent to angle 6 and 6 is congruent to angle 7, I can say that 4 is congruent to angle 7 as well. Now this is going to work the same way as it did on our practice test for the regular test, the same way as it did last week. So I did the practice here where I gave you the reasons and you filled in the statements. Expect to fill in the reasons given the statements on the test. So in other words, expect to have these 4 statements given, and you'll fill in these 4 reasons for the question. All right, fill in the statements. All right, fill in the true statements is what it says. So if 2 lines intersect to form a linear pair of angles, what happens? And then the options here are going to be underneath. So there's going to be 6 or 5 options to fill in the statements. So one of the options is going to be the angles are complementary. One's going to be the angles are supplementary. One's going to be the angles are congruent. One's going to be the lines are perpendicular. So let's talk about which one of these is going to be the angles are complementary. So if 2 angles form a linear pair, that's not complementary, no. If 2 angles, that's supplementary, means 180. If 2 lines are perpendicular, that doesn't mean they're complementary, the lines, no. If 2 sides of 2 adjacent acute angles are perpendicular, 2 sides of 2 adjacent acute angles are perpendicular, that is complementary, because perpendicular, 2 sides of 2 adjacent angles. So this here means they are complementary. The angles are complementary. All right, our next statement is the angles are supplementary. So which of these has the conclusions that the angles are supplementary? So let's look at the first one. If 2 lines intersect to form a linear pair of angles, 2 lines, linear pair of angles, well, the angles would be supplementary. If 2 angles form a linear pair, the angles would also be supplementary as well, because linear pair means supplementary. If 2 angles are supplementary to the same angle, well, they're already supplementary. I can't conclude here that they're supplementary. And if 2 lines are perpendicular, well, the lines aren't supplementary when they're perpendicular. No. So we have to decide which of these is talking about the angles. This is talking about the lines. If 2 lines intersect to form a pair of linear pair of angles, this is asking about the lines. What are the lines? This one's asking about the angles. The angles are supplementary. If 2 angles form a linear pair, then the angles are supplementary. All right, our next statement is going to be then the angles are congruent. So again, this is talking about lines. If 2 lines intersect, I'm not asking about angles here. If 2 lines intersect, what happens with these 2 lines after we define how they intersect? If 2 lines are perpendicular, I'm asking what happens with the 2 lines. So again, our conclusion we're looking for is they are congruent. If two angles are supplementing the same angle, yeah, they are congruent. The angles are congruent. All right, our next conclusion here is the lines are perpendicular. If two lines are perpendicular, why would I conclude the conclusion here that they're perpendicular again? We've already said they're perpendicular. If two lines intersect to form a linear pair of angles, if two lines intersect to form a linear pair of angles, then or if two lines are perpendicular, then they intersect to form four right angles. And I'm lacking one here that says the lines are perpendicular. Then the lines are perpendicular. So if two lines intersect to form a linear pair of angles, then I could conclude as well there that the angles are supplementary. But could I conclude that the lines are perpendicular? And so this statement has not been finished. It should say if two lines intersect to form a linear pair of right angles or congruent angles. So I'm going to reword this. If two lines intersect to form congruent angles, then the lines are perpendicular. And I'm going to reword this on the test as well. You're supposed to match the statements from the notes that we had in our notebook on page and I'm looking up the page here. Page 18. Statements I gave you on page 18. What is page 18? It's not page 18. We will find it here. There they are. It was on page 32 in my old notebook. So if two angles are supplemented to the same angle, then the two angles are congruent. If two angles are complemented to the same angle, then they're also congruent. That was the statement here. If two angles supplement the same angle, then the angles are congruent. The second statement here is if two angles form a linear pair, then they are supplementary. So if two angles form a linear pair, then they are supplementary. The third statement here is if two lines intersect to form a linear pair of congruent angles, so that should have been if two lines intersect to form a linear pair of, that should have been congruent angles. I forgot a symbol there. Then the lines are perpendicular. Anyhow, and that was supposed to match the statements from our notes. Next item. Write down an example of the addition, subtraction, transreflexive, symmetric, and substitution properties. So these are in the properties in your notes. You can look at them up in your notes. I'm not going to write down samples for you. Addition, again, when you add to both sides. And when you construct a segment congruent to another segment, you take its measure and you copy and paste. So this particular segment measures, well, that is, if I take my ruler and rearrange it properly so you can actually read it, that's about 26 millimeters. So I'm going to make another segment of 26 millimeters. Oops. I'm going to have to get the ruler. There we go. 26 millimeters. 26 millimeters in length. And again, with these properties, you're just writing down the properties from our notes. And on this test, it's multiple choice, just like the last week's test. So for the Addition property, you're adding something to both sides. Dividing property, you're dividing to both sides. Anyways, good luck. If I confused you about these statements here, come in and ask me some more about them. And we'll talk about them some more with the statements that they're supposed to be and how you're supposed to match them.